Inline functions is a very important feature in C++. Basically, inline function is a function that is expanded inline when it is called. For example, when hello, which is inline, is called, the content of hello gets expanded at the location where it is called. So instead of having hello here at compile time, hello would be replaced by cout, or the content itself. Now, the important question to ask, why? Why are we using inline? The short answer is efficiency. To understand why, we need to know what happens at runtime. So at runtime, when a function is called, each function carries a memory address. It also has instructions on where the parameters are, the copies of the arguments inside the functions, and all of these are sitting on a stack. So you can think of this stack as a memory space keeping track of the runbook that carries the memory address of where the function is, and also the instructions in which the function is using to execute the business logic. So there's a lot of that information that gets stored per function at runtime. And when a function is called, your CPU then goes into this memory stack and look up the location of the function and what this function is doing. So there is a little bit of a context switch. And context switch is defined by the amount of time it takes for CPU to execute a function. This context switch is an overhead if the execution time of the function is less than this switching time. In the hello world example, this inline function only prints hello to the display, and this is a very, very quick operation. The amount of time it takes for CPU to context switch and call hello would have exceeded the amount of time it needs to print hello. So let's say the printing of the cout hello takes 1 millisecond. And if the context switch takes 2 milliseconds to execute, then there will be a value in having inline function in place, as in the case of hello function. Sometimes this may not be the case. In other words, this context switch time is very, very short. And the business logic inside a function is very, very long, and it takes on the order of several seconds, for example, to execute. Then there is a value in inlining the bigger function, or the function that has a large amount of instructions for execution at runtime. In C++, we introduced the concept of inline by using this keyword inline, and the substitution of the business logic with that of the function invocation occurs at compile time. So this substitution is performed by the C++ compiler at compile time. For small inline functions, this may increase the efficiency overall. On the flip side, if you're using a lot of inline functions, just imagine that at compile time, there will be a lot of substitutions. So imagine all of your function call will be replaced by the payload of the function throughout the entire code base, making your overall binary executable file to be rather large because of the duplication of same code throughout your files. As we know, the larger the executable file is, the more memory it requires at runtime to execute. Therefore, it slows down the execution time of your code. So there's always these pros and cons that you have to consider, whether making your function inline or not. There is a wealth of information online that talks about the pros and the cons of inlining a function in C++, and those are in your reading assignments.